CFA Level 1 Practice Questions. Learning Module, Simple Linear Regression. Topic, Estimation of the Simple Linear Regression Model. An analyst estimates a regression of net profit margin, NPM, percent, on fixed asset turnover, FIDO, times first sample of firms. The regression equation is NPM equals 0.6 plus 0.3 times FIDO, plus error term. If a company has FIDO equals 3, observed NPM equals 2.2%. The residual is closest to A negative 0.1%, B 0.7%, C 1.6%. An analyst builds a regression model to examine whether changes in interest rates help explain changes in housing prices. In this model, the changes in interest rates are best described as an dependent variable, B independent variable, C indicator variable. Which of the following best describes this regression? A time series regression, B cross-sectional regression, C time series and cross-sectional regression. In this model, 0.0680 is the standard deviation of the dependent variable, B predicted dependent variable, C residuals from the regression. The correlation between X and Y is closest to A negative 0.8279, B 0.6124, C 0.8279. Based on Exhibit 1 and Exhibit 2, if Rivera were to graph the 60 observations, the scatter plot summarizing the relationship between debt ratio and short interest ratio would be best described as A horizontal, B upward sloping, C downward sloping. Based on Exhibit 1 and Exhibit 2, the correlation between debt ratio and short interest ratio is closest to A negative 0.3333, B negative 0.1111, C 0.3333. The dependent variable in Rivera's regression analysis is the A intercept, B debt ratio, C short interest ratio. An analyst runs a simple linear regression to test whether the number of hours studied per week correlates with the variation in students' final exam scores. In this model, the number of hours studied per week is an dependent variable, B independent variable, C response variable. Residual is the difference between the observed value and the predicted value. Residual equals observed y minus predicted y. Residuals must be in the same unit of measurement as the dependent variable. The positive residual correctly indicates that the actual observed value was higher than the predicted value, meaning the company's performance exceeded the model's average expectation. The variable used to explain variation is the independent variable, x, while the variable being explained is the dependent variable, y. In financial modeling, the independent variable is viewed as the driver or explanatory variable. Since interest rates are used to explain housing prices, they are the independent variable. Indicator variables are distinguished by their binary nature. They only take values of 0 or 1 to represent specific categories or characteristics. Because interest rates are numerical values, like the CAPEX or ROA examples in the text, they do not fit the definition of an indicator variable unless specifically coded as such. Time series data involves many observations from different time periods for the same company. In this case, the regression focuses solely on one entity, Aurora Fuels Corp. Time series regression is defined by its use of many time periods. For example, the 240 months mentioned in the question for a single subject. Cross-sectional regression requires many observations for the same time period coming from different companies. Analyzing a single stock's returns over a sequence of months is classified strictly as a time series regression. Standard error of the estimate, SE, also called the standard error of the regression, is explicitly defined as the standard deviation of the regression residuals. Measurement of fit measures the distance between observed values of the dependent variable and those predicted by the regression line. Residual standard deviation is a critical absolute measure of goodness of fit used to calculate prediction intervals. Coefficient of determination, R squared, is the square of the pairwise correlation, R. To find the magnitude of the correlation, you must take the square root of R squared. The sign of the correlation coefficient must match the sign of the slope coefficient. Because the slope in this problem is negative, minus 0.095, the correlation coefficient must also be negative. Both the slope and the correlation formulas share the same numerator, covariance. Since the denominators for both are always positive, if the covariance is negative, both the slope and the correlation will be negative. R squared measures the strength, the percentage of variation explained, while the slope determines the direction of the linear relationship. The sign of the covariance or correlation determines the scatter plot direction. A negative covariance or correlation indicates a downward sloping relationship, meaning as the independent variable, debt ratio, increases, the dependent variable, short interest ratio, decreases. The sign of the covariance or correlation determines the scatter plot direction. A negative covariance or correlation indicates a downward sloping relationship, meaning as the independent variable, debt ratio, increases, the dependent variable, short interest ratio, decreases. Sample correlation, R, is the ratio of the covariance between two variables to the product of their standard deviations. In a simple linear regression, the square of the pairwise correlation is equal to the coefficient of denomination, R squared equals R squared. The sign of the correlation coefficient must match the sign of the slope coefficient. The sign of the correlation coefficient must match the sign of the slope coefficient. Because the denominators for both the slope and correlation are always positive, the sign of both is driven by the numerator, the covariance. Therefore, if the covariance is negative, the correlation must be negative. Dependent variable, y, is the variable you are seeking to explain, while the independent variable, x, is the one used to explain that variation. Distinguish between a variable, an observed data point, like debt ratio, and a coefficient, a parameter, a like the intercept, b0. The intercept is not a variable but a component of the regression equation. Interest ratio is the dependent variable because the analyst's primary objective is to understand how it is affected or driven by other factors. Independent variable, x, hours studied per week, used to predict exam scores. Dependent variable, y, final exam scores, the outcome being explained. Response variable, another term for dependent variable, not applicable to hours studied. Topic: Assumptions of the simple linear regression model. The linearity assumption in simple linear regression is least likely described as: The relationship between the independent variable is linear in parameters. B. The parameters, intercept, and slope enter the model in a linear form. C. The scatter of residuals is normally distributed. Which of Maria's regression assumptions would be incorrect if she stated that the dependent variable must be normally distributed? A. Assumption 1 errors uncorrelated. B. Assumption 2 errors homoscedastic. C. Assumption 3 dependent variable normally distributed. Linearity refers to the relationship being linear in parameters. Y equals B0 plus B1x plus epsilon, not to the distribution of residuals. Normality of residuals is a separate assumption, not part of linearity. The normality assumption applies to the error term, residuals, not to the dependent variable itself. Regression does not require Y, dependent variable, to be normally distributed. Normality of residuals is what ensures valid inference for hypothesis tests and confidence intervals. Topic: Hypothesis tests in the simple linear regression model. At the 5% level, which conclusion is most appropriate? The slope is not significant because r to the power of 2 is less than 1.0. B. The slope is significant because t exceeds the two-sided critical value. C. The slope is not significant because p-value is less than 0.05. The coefficient of diminution indicates that A. Aurora's returns explain 3.20% of the variability in retailing. B. Changes in retailing explain 3.20% of the variability in Aurora's returns. C. Changes in retailing explain 17.9% of the variability in Aurora's returns. An analyst is studying the government budget deficit as a percentage of GDP for a country over the past 25 years. 10 years ago, the country introduced a major fiscal reform law aimed at tightening budget discipline. The analyst estimates a regression model where the dependent variable is the annual budget deficit and the independent variable is a dummy variable. Reform, defined as 0 for years before the fiscal reform and 1 for years after the fiscal reform. The regression results show an intercept of 4.200 and a slope coefficient for reform of negative 2.800. The variable reform is best described as A. A continuous variable. B. An indicator variable. C. A dependent variable. The interpretation of the intercept is the A. Average budget deficit before the reform. B. Average budget deficit over the entire sample. C. Average budget deficit after the reform. The interpretation of the slope coefficient is the A. Average budget deficit after the reform. B. Change in the average budget deficit due to the reform. C. Annual change in the deficit over the 25-year period. Testing whether the reform changed the budget deficit at the 5% level of significance, the analyst should conclude there is sufficient evidence that the budget deficit changed. B. Not enough evidence that the budget deficit is different from 0. C. Not enough evidence that the reform changed the budget deficit. The coefficient of diminution for the regression of debt-to-equity ratio on interest coverage is closest to A. 0.6852, B. Negative 0.0950, C. 0.8280. The coefficient of diminution, R squared, is closest to A. 0.1151, B 0.7703, C 0.8850. An analyst is studying whether a company's classification as a value stock affects its dividend yield. She estimates a simple linear regression with dividend yield and percent as the dependent variable and an indicator variable, value as the independent variable. Value equals 1 if the company is classified as a value stock and 0 otherwise. The estimated regression equation is dividend yield equals 2.3 plus 1.1 times value. When performing this simple linear regression with an indicator variable as the independent variable, the slope coefficient, 1.1, can be interpreted as the A mean dividend yield for value stocks, B mean dividend yield for non-value stocks, C difference in the mean dividend yield between value stocks and non-value stocks. Significance is determined by comparing the absolute value of the T-statistic to the critical value, or by checking whether the p-value is less than the significance level. R-squared measures goodness of fit, not statistical significance of the slope. Coefficient of determination, R-squared, represents the percentage of variation in the dependent variable, y, that is explained by the independent variable, x. It does not work in reverse. Aurora's returns is the dependent variable, the one being explained, and retailing as the independent variable, the explanatory factor. R-squared is a descriptive measure of goodness of fit, specifically the explained variation divided by the total variation. An indicator variable is binary, takes only value 0 or 1, and is used to represent a qualitative event or categorical distinction. It serves as an independent variable, not the dependent variable, and is not continuous. Reform equals 0 means before the policy change, so the intercept represents that period. When reform equals 0, the regression reduces to just the intercept, predicted budget deficit before reform. After reform, the value is intercept plus coefficient, not the intercept alone. Options B and C are incorrect because the intercept doesn't represent the overall average or the post-reform period. The slope coefficient for an indicator variable represents the difference in the mean of the dependent variable between the two groups before versus after the reform, not the level for either group alone. The mean after the reform is the intercept plus the slope. Significance is determined by comparing the absolute T-statistic, 4.00, to the critical value, 2.064. Since the calculated T-statistic exceeds the critical value in absolute terms, the null hypothesis of no reform effect is rejected, providing sufficient evidence that the budget deficit changed. R to the power of 2 measures how well the independent variable, interest coverage, explains variation in the dependent variable, debt-to-equity ratio. R to the power of 2 equals 0.6852. 68.52% of the variation in debt-to-equity ratios is explained by interest coverage. Option B, minus 0.0950, is the slope coefficient, not R to the power of 2. Option C, 0.8280, is not supported by the regression output. R to the power of 2 is found using the formula SS R divided by SST, with SSR equals 40,050 and SST equals 45,250. The calculation gives r to the power of 2 equals 0.8850. This means 88.5% of the variation in sales per square foot is explained by the market demographic score. Options A and B are incorrect because they don't match the computed ratio. The slope 1.1 represents the difference in mean dividend yield between value stocks, value equals 1, and non-value stocks, value equals 0. Value stocks, intercept plus slope equals 2.3 plus 1.1 equals 3.4. Non-value stocks, intercept equals 2.3. Intercept equals mean of group coded as 0 non-value stocks. Slope equals difference in means between group coded as 1 and group coded as 0. Intercept plus slope equals mean of group coded as 1 value stocks.